Let's talk about something that frustrates so many parents and teachers. Why on earth is math so hard for so many kids? Well, the answer isn't really about being good or bad at math. It's actually all about how our brains are wired to learn. So today, we're going to uncover the science behind the struggle.
Come on, be honest. You've been there, right? That feeling of frustration watching a kid just stare at a page of fractions, or algebra, completely lost. It's so common. But what if I told you that whole idea, that someone can just be bad at math, is completely wrong?
I mean, think about it. When we first learn math, it's this beautiful, simple world. The rules make sense. You have 2 cookies, you get 2 more. Now you have 4 cookies. Bigger numbers always mean more. Everything is consistent. It's logical. You can count it on your fingers. For years, a child's brain builds this solid, really reliable idea of how numbers work. And then
everything changes. All of those dependable rules they've spent years mastering, suddenly they just seem to break. And that's the moment when the confusion really sets in.
This is the classic paradox. Every kid knows that the number 4 is bigger than the number 2. That's a core rule. But then you show them fractions, and suddenly a 4 on the bottom makes the whole thing smaller than a fraction with a 2. This feels like a betrayal. It completely contradicts the rules the brain has worked so hard to learn.
So what is going on here? Is math just designed to be confusing? Well, no. The answer isn't in the numbers themselves. It's in the incredible, super efficient, and sometimes, really stubborn way our brains are built to learn things.
the key word we need to know is schema. Think of a schema as a mental blueprint, or maybe like a folder in a filing cabinet. Our brain creates these frameworks to organize information and connect new stuff to what we already know. It's what makes learning so efficient. For example, once you get tens and ones, it's pretty easy to get hundreds and thousands because you're just adding to a schema you've already built.
But here's the catch. Our brain's biggest strength is also its biggest weakness. Our brains are loyal to the schemas they've already built. They will literally bend, twist, and distort new information just to make it fit into an old pattern, because that's way easier than building a whole new one from scratch.
So, you can see where this is going. When a child sees a fraction for the first time, their brain doesn't see a totally new system with new rules. It sees numbers it recognizes, so it automatically tries to apply the old rules, the whole number schema. It tries to shoehorn this brand new idea into that old, comfortable box. And that's exactly where the trouble starts.
This whole shoehorning thing, it creates what we can think of as math monsters. These really persistent misunderstandings that are born from that clash between the old rules and the new concepts. Let's meet a couple of the most common ones.
Oh, fractions. They're probably the biggest monster of all because they break that whole number schema in 3 huge ways. First, the value thing we talked about. A big number like 10 on the bottom means a smaller piece than a 3. That's just weird. Second, the idea of the whole becomes slippery. A half isn't a fixed thing anymore. Half of a small pizza is way different than half of a giant one. And third, you've got equivalence. The idea that 1 over 2 is the exact same amount as 2 over 4, that's just crazy talk to a brain that knows for a fact that 1 is never the same as 2.
Here's a great example of that confusing whole concept. Okay, imagine 2 pizzas being shared by 3 people. Now, logically, each person gets 1/3 of all the pizza that's available, right? Makes perfect sense. But we write the answer as 2/3. Why? Because we're expressing it as 2/3 of 1 pizza. The whole we're talking about just shifted. And if nobody explicitly explains that, a kid's brain has no chance of figuring it out.
All right, monster number 2 is the equal sign. And this one is a sneaky one. For years and years, we teach kids that equals is an operator. It's basically a button you press that means, do the calculation, or here comes the answer. But to ever understand algebra, you need a totally different view, the relational view. You have to see that the equal sign just means is the same value as. It's about balance. Without that mental shift, algebra is basically impossible.
And research shows that this understanding actually grows in stages. You start at that super rigid, get the answer view. But eventually, you get to that fully relational level, where a student can look at that bottom equation and without doing any adding at all, they just know the answer is 68. They understand the principle of balance. It's a beautiful thing when it clicks.
So how many kids actually get there? Well, one study found that on average, elementary students were only 27% accurate on problems that required that fully relational view. That is a huge gap, and it's all because the brain is stuck in that early, outdated schema of what equals really means.
Okay, so if these broken schemas are the problem, how in the world do we fix it? Well, the great news is we can actually be proactive. We can help kids forge new, better, stronger pathways in their brains right from the start.
All right, step 1 is the most important one. Teach conceptually. It's all about building the right mental blueprint from day one. Educator Claire Seeley says this means 3 key things. First, take incredibly small steps. Break everything down. This stops the brain from getting overwhelmed and defaulting to that old, wrong schema. Second, you have to ensure mastery at every single tiny step. Think of it like building a brick wall. You can't put the next row on until the one below it is totally solid. If you rush, you're just building cracks into the foundation. And third, use physical models. Make the abstract real. When a kid can actually bundle 10 straws to make a 10 or cut a piece of Play-Doh into fourths, the concept isn't just numbers on a page anymore, it's real, and that builds a much stronger and much more accurate schema.
Okay, step 2, make practice engaging. This is where something like gamification becomes an amazing tool. And it's not just about making math fun. It actually taps directly into the brain's reward system. You know, the points and badges provide motivation, but more importantly, games give immediate feedback. Instead of doing a whole worksheet wrong, a kid knows instantly if they made a mistake, so they can fix their thinking right then and there. It also gives them the massive amount of repetition they need to master a skill, but without the soul-crushing boredom of a worksheet. And maybe best of all, it gives them a sense of control, of autonomy. And that feeling of mastery, that is one of the most powerful motivators in the world.
So, when you pull all of this together, what's the big takeaway? Well, it's really about a fundamental shift in how we look at the problem. It's about rethinking what it even means to struggle with math.
This is so important. Getting it wrong isn't a sign that a kid's brain is broken. It's actually a sign that their brain is working perfectly. It's doing exactly what it's supposed to do, trying to apply a successful old pattern to a new problem. The problem isn't the brain. It's just that the old map doesn't work for this new territory. And our job is to help them draw a new one.
And that leaves us with one last, kind of provocative thought. For generations, we've just accepted this idea that some people are good at math and some are bad at math. But what if that idea is just another faulty schema, a fixed mindset that we've all learned and accepted? Maybe the very first step to helping our kids is to break that schema in ourselves.